Hi, everybody. So last night on Google Classroom, you all did a quick 10-minute notes page that got us ready for this real-world day of notes. And on Google Classroom, I also posted this YouTube video of this GoPro rider, Danny McCaskill, riding an amazing ride through the Gran Canaria Islands. I'm just going to show the first 20 seconds so you remember what you watched.
Our father is endless thing. He's just squandering, he's just wandering, and we don't do a thing. People busy and things, we're just wandering, we're just wandering, like he tells us he lies, he's got his paradise, he's in his heart tonight, and he thinks in his home that he's just getting by, and he's a compromise, he's such a compromise.
Okay, his entire ride through the city is that insane. It took GoPro worked with him for months to build this course over these rooftops. But the focus that we're going to pay attention to is like this amazing jump at the end of his ride. This video is on Google Classroom, so you can watch the whole ride. You see that? He's not dead. What? He's not dead. So in Google Classroom, this link is live right there. You can watch it. That jump into the ocean fall into the ocean is what we are going to, it was a motion, but he didn't actually have any upward velocity. He literally went off that ramp and fell. So that arcing motion you see on the front of your notes, that fall is what we're going to talk about today. Let's get right to it, right? We have 3 starter warm-up questions to discuss. Welcome to Gran Canaria, Smart Island, coast of Spain. What shape of graph would model his jump? I heard it, started with a P. Parabola, very good. So if you wanted, that parabola is this shape. If I were to sketch it in red. But did he do this complete motion? No. That ramp was right there. So really, he had this initial spot, and now he's falling into the ocean. So half of a parabola. What does that general equation look like? What's a general equation for a quadratic? Who's got it? F of x equals ax squared plus c. Ax squared plus bx plus c. But we just talked about this. Did he actually complete the full shape? No. So because he didn't, do you think that'll have effect on the parent function? Yes, it will. So let's jump right into our model. Falling object model. That's what this note page is on Google Classroom. Turn the page. Yep, 10-minute video. And our falling object model is f of x equals, I'm going to wait because I see pencils are not moving yet. You got to write with me. Write with me. Does it matter if I say f of x? Does f have to be f? Does x have to be x? So we're going to change it up and do h of t. and you'll understand why in a second. Negative 16t squared plus h, and we're going to say h naught. It's a math term where we say h in that little sub-zero.
So we can't put f?
No, and you'll see why in just a second. The question was, can we put f? And I'm going to say no to that because there's a reason we're using h. H of t is height. There you go. See, you beat me to it. Height at any time during the fall, or current height, however you want to say it. Means the same thing. Important notes. If you don't have a highlighter, you should get one out. Yep. Height at any time during the fall, or current height, comes from question being asked. And I'm going to highlight that. H of t always comes from the question being asked. Always. H naught, or the H with the little sub-zero, is initial height. What does initial mean? What does initial mean? Starting height. Very good. So in my picture here, where was his starting height? What part of the fall? Right here at that ramp. Very nice. Good. And then guess what T stands for? Time. The key for what we're going to do today is the fact that technically, check out what's not here. Could I write 0t as a placeholder? Yes. We have no B term. Remember yesterday when we were talking about solving by square roots, you have no middle term? That's why these real-world falling applications fall under this topic of solving by square roots. And we're going to see how that works by looking at our first real-world scenario that's tied to that video of Danny Caskill on the rooftops. So let's read the actual question together. Welcome to Gran Canaria, a small island in the Atlantic. GoPro athlete Danny McCaskill is finishing his ride with a fall into the ocean. The ramp he's riding off of is approximately 75 feet above the ocean. How long until he hits the water? So we're going to use this model. Remember how with compound interest, we kind of put a list off to the side of values? How many values do we need to identify to use this model? 2, 3? Well, let's see. Let's start off with what we're told. What piece of given information do we have in this question? He's approximately 75 feet above the ocean. Is that a current height or initial height? Initial. Very good. As Angel mentioned, that's the height he started the fall at, right? Way at the top. His jump started up. His fall started right here, 75 feet above the ocean. How long until he hits the water? Now, talking about hitting the water is something that was in that 10-minute video from last night, but we can reason on this from a real-world understanding. What height is water at? 0. So we're saying h of t, the current height based on the question, is 0. To help us out, I'm going to write the general model first. Can everybody say this with me? H of t, let's do it. H of t equals negative 16 t squared, good job, plus h naught. Why they say naught, it's a good question to look it up, but this is called h naught. It's h with, how you spell naught? It's a good question. Look it up. H naught. Okay, what pieces do we know? What can I plug in? I'll wait. Pencil's moving with me, folks. 0 equals negative 16t squared plus 75. Using all of those awesome skills that we practiced last night, can I solve this? Yeah. How am I going to do that? Let's do it. Subtract 75. How we show work matters. Be neat. If I drew a line, you draw a line. If I draw a line across, you draw a line across. What is 0 minus 75? Yep, and if we haven't taken our calculators out yet, we definitely are going to need them. Good? Finish. You finish, see what you get. We will have a decimal answer. What are we going to divide both sides by? Be very careful that we keep track of those negatives. What happens if by accident I didn't put negative 16 under here and I just put 16? I'm going to get the wrong answer. Because what I'm going to get right now, what is a negative divided by a negative? Yeah. So can somebody with their calculator tell me what is 75 divided by 16? 4.6875. Did you notice how I didn't even say negative 75 divided by a negative 16? Because in my head, what conversation did I have? That a negative divided by a negative is positive. So you can mentally decide. I already know what's going to happen with those signs. We said 4.6875. Is this all done? No. Good job. Square root of both sides. I hear a vote for t equals 2 point plus or minus 2.165. Do I keep the negative answer though? No, because we can't. What does t represent? Remind me. What does t represent? Time. Can we have negative time? Definitely not. So our real world answer is 2.1675 seconds until he what? Oops. 165 seconds until he. Very good. And we're done. Let's start reading number 2. So this question is all about a bag jump. We're going to read it and then I'm going to show it to you. You lose a bet and now have to go participate in an insane bag jump where you fall from 100 feet above the ground. Does anybody know how many stories that is? In a building? 10. So that's like going to the 10th floor of a building and jumping out the window. You will hopefully land on the safety cushion. The safety cushion is 26 feet wide, 30 feet long, and 9 feet high. So let's watch.
What you're going to have to do is make sure you get your legs right out.
That's nothing.
I would do that.
Show of hands, who would do it? You are all crazy. Absolutely not. I will watch. I'll hold your keys. I'll hold your phone. No way. Exactly. So look at the question. Look at where we're going to see how many seconds. If he misses a cushion, what happens? How long till he hits the ground? Okay, so let's talk about this. We're told to model it. It says, write the quadratic function that models the situation. Now, at the top, the model doesn't change. So what was the model again? H of t equals negative 16. Tell me out loud. T squared plus h naught. With your highlighter, I want you to highlight. To successfully solve falling object questions, we only have to correctly identify 2 pieces of information. That's not bad at all.
We can get 16 from this.
Yes. Great question. Great question. People are asking, where did negative 16 come from? Eventually, I think it's tomorrow, we're going to look at a real-world question that helps you understand where that negative 16 comes from. It's connected to Earth's gravity. It's a physics thing. So if we change planets, like we're going to look at falling objects or something with velocity on a different planet, that's when the negative 16 changes. Right? Great question. All right. So from this question, can you give me my 2 pieces of information that I need? So that 100 feet I hear being mentioned, what is 100 feet a value for? Yeah. Now, A is just asking for a general model. So it's as simple as saying, oh, my initial value is 100 feet. So what's the model? H of t equals negative 16 t squared plus 100. Did you build the model? That's it. Now we're going to use it. So B says, how many seconds will pass until you reach the cushion? What do you know about that cushion? It's 26 feet wide, 30 feet long, 9 feet high. I only care about one of those numbers. Very good. The 9 feet high piece, because that's the current height. So I would like you to please circle cushion, and say equals what? 9. So we're actually going to set our model equal to 9. What am I going to write? Tell me what to write. 9 equals negative 16 t squared plus 100. Can you guys go solve that? Yes, you can. Find how many seconds till he hits the cushion. They didn't. Those people didn't die. As long as you hit the cushion, you're okay. What if the cushion? Hence the reason I will never do it. Okay. No gracias. Come on, let's go. Let's go. Solve. We're gonna subtract what from both sides? 9 minus 100? What do I need to divide by? Good job for keeping track of the negative. Now, mentally, I can tell myself negative divided by negative is positive. Don't even bother putting those negatives into the calculator. I get t. Is it t or t squared? T squared. Good. Don't drop that squared. Who's got 91 divided by 16? Am I done? No. Square root both sides. So for those of us who've been doing a really nice job of showing our work, we'll find that paying off right now. Who's got the square root of 5.6875? Jamar? So let's say 2.385. What's my label? Seconds. Why did I not even bother with the negative? Because in the real world, can you have negative seconds? No. Now, the C question says, how many seconds will pass if you miss the cushion and you hit the ground? I know, kind of. Oh, okay, so people are asking where the 5 came from. What came after the 4? 8. So that 8 causes the 4 to become a 5, good. 3 decimal places is what we're going to round to. Then we'll practice. She's saying she's not so good with rounding. That's what we'll practice then together. Now, ground is where? So tell me my model, tell me my equation now. Go for it. We should be done with this in less than a minute. I'll race you. Probably going to lose. The only way you win is if you're not looking up when you do this.
I don't know how to do this so it gets to the real world.
Well, that's what we're learning how to do together right now.
If it's, what is this, the answer and everything? Well, not the answer, but like,
But so that's a good question, because so what we're learning today is not how to solve these. We've been practicing that for 2 days. What we're learning today is how to set it up. So did you write at the top? Did you write this at the top? Did you highlight this? The key to setting up the model, all you have to do to correctly set up a falling object model is correctly identify the initial height. You'll always be told a starting height from where that object is falling, always. And then what's the question asking? So for example, here it was when did he hit the cushion? Well, the cushion is 9 feet. 9 equals. When did he hit the ground? Ground is 0. 0 equals. And then you can solve. So let's practice that with number 3. All right, folks, read number 3. This is a true story. He set the world record. Everybody read number 3. Brazilian-born Laszlo Schaller recently decided to tackle Switzerland's famed Cascata del Salto waterfall for a world record cliff jump attempt of 60 meters. That's 196.85 feet. How many stories is that? What floor of a building? The 20th floor. So now we're not even talking 10th floor. 20th floor, and you jump. With the help of his crew, Schaller spent days building a high dive platform and studying the cliff face before stepping off the platform, which, to be exact, was a height of 58.8 meters, 192.91 feet. To further ensure his safety, the team also set 6 tanks in the pool to aerate, like put air in the water to try to make it softer. It is estimated Schaller reached a speed of 76.43 miles per hour before he hit the water. And even though his feet first entry was perfect, he actually missed the landing zone, like where they were making the water soft, and plunged into harder water in the center of the pool. The impact was akin to a gunshot, resulting in a mad scramble by rescuers who had to drag him back to dry land. Schaller was on his hands and knees for several tense moments before managing to climb onto his feet, raise his hands, and say, "I did it." How many seconds? He lived. He did live. He lived. But the question is, how long did it take him to hit that water? Now, as much information as we have here, remember, what are the only 2 pieces of information I need to find? Very good. H naught and current height. Now, we have a speed of when he was falling, but for falling objects, there's no need for how fast something was falling. That doesn't matter here. Just where he start and where is he landing. Who's got his starting height? Careful. I'm hearing 196. Yeah. Where was his ramp thing? Platform. 192. Circle it so it stands out to you. 192.91 feet. And then from the question, I get H of T. The question tells me how many seconds did it take for him to hit water. Water equals 0. So on your own, build your model, and then we'll see if it matches. Write it up. Write your model, and we'll see if it matches. Go for it. Once our models match, I would encourage you not to look up until you finish, and then we'll see if our answers match.
When you read out the, like, this long, you have to write the whole thing.
3 decimal places. Very good. Well, what comes after the 2? What was the next number after the 2?
1.
A 1, so then the 2 stays. Are we matching?
Yeah.
Sweet. You got it. If you can do these 3 guys, you can do all of them. It's reading for information, realizing it's a falling object. Now, next week, we're going to learn about things that have velocity, like rockets and all that. But these are just falling objects. So before we watch the video, tell me, what are the 2 pieces of information you need again? H naught, which is what? What is H naught? Initial height, and then H of T, which is current height, or like comes from where? Where does H of T come from? The question. Did everybody hear what he said? Say it louder. Where does H of T come from? The question. All right, let's watch this guy's dive.
The homework from the day before yesterday.
So he still holds the record. Nobody's beaten his record yet. Nah. If you show me that, just don't get hurt, please. Don't get hurt. Yes. All right, we have a couple more. Now these ones are in here, so you remember that if you're given a model, are you supposed to go write your own? No. Now, we're going to get through these couple. I know we're on a connections day, so it might cut a little short. If that happens, I'll make sure that I just add these to a little video on Google Classroom. Go ahead and read number 4. I think I'll probably have time to do number 4, and then the last one we can just add to Google Classroom. The equation h of s equals, ooh, look, I got an equation. What should I do with it? Highlight it. All that work has been done for us. Gives the height of the largest ocean wave. So I'm told h of t equals height. As soon as it defines variables for you, you want to write that down. Height of wave. What does s represent? Oh, I should say s. H of s. And then s represents, read carefully, speed. Has anybody heard of knots as a way of measuring, like, speed on the ocean? Do they? No, that's a good question. Airplane speed? Knots. Like on a boat in a movie, they'll say going 5 knots. I don't actually know what that means. But it's how they measure speed. And I did look up how to convert it into miles per hour. We'll look at that in a second. How fast is the wind blowing if the largest waves are 15 feet high? I've got my model. What piece of information did it give me? Is that a value for h of s or s?
S.
Careful, h of s, which represented height. H of s. So circle that, that's h of s. Now, if it had said how far, if they're traveling 5 knots, what's the height? Then you would have a value for what? S. So defining your variables correctly is a direct connection to plugging something in right. So what am I going to write? But I know h of s. What is h of s? 15 equals. Can we solve this? What do we have to do first? Let's do it. Divide by what? So in terms of what we divide by, remember, we're paying attention to where s squared is. Our goal is to isolate the squared variable. So somebody help me out with 15 divided by 0.019. Who's got it? 789.47, but what comes after the 3? 6, so that 3 becomes a 4. Good job. Equals s squared. Am I done?
No.
What do I have to do? Square root both sides. So s equals, let me know what you get. What comes after? So 097, but what's after the 7? 5, so what happens to the 7? Good job. And what's the label? Knots. And again, if you defined your variables off to the side, you'll know what the label is. So these questions are nothing new to us. It's a reminder, right? Recall. What does it say at the top? If you're given the model, use it. So to wrap up today's notes, there was just one more question that had you practicing that. We're going to do a raffle ticket for anybody who comes in with 5 A and B done or solidly attempted on Monday. I don't want to add to Google Classroom something else because we're going to go back and make sure we watch that one from last night, right? Tonight's homework. Look at the next page. I want to see that everybody has eyes on their homework before their packet's away. I didn't hear the bell. Let me packet. Show me that you see. Point to your homework so I see that you do it. Yep. This is it. Yep. Homework. Homework. Yep. Good. Homework. Yes? Yes, both pages. Homework. Homework. Good job. Ms. J142? Yes? Both of these are homework. Yes, yes. Hello. Okay. One sec. All right, guys. Are we all clear on the homework? Yes. I didn't hear the bell, though, so we should be starting it. Take it out. People who have it out, let's start. Nice job today. This video will be on Google Classroom. Just to show you, so we're crystal clear, 6.1, day 3 homework. How many questions are for homework? 100. No. How many? How many, guys? 7 questions for homework, which we should be starting right now. Thank you. And it's fun. Like, if I like watching something that's insane versus, like, there's some people who think the videos are